2 questions you guys have in your review? Is that true? Yes or no in your notes today? Okay, so I'm going to show you the difference between these 2 problems, okay? All right, right here, okay, you see they're the same. The only difference is this is squared here, okay? Right here, if I make u equal to x squared plus 1, which means I make the whole bottom my u, okay? Then the derivative of this is what? What's the derivative of x squared plus 1? 2x, right? If I solve for dx, and you guys are good at this now, or some of you guys, those of you guys who didn't fail your test, okay? You're really good at this. What you do is you cross multiply and you'll get dx is equal to du over 2x, okay? If you replace 2 things, if you replace your whole denominator and your dx, what you'll get is 2x times u times du over 2x, right? The 2 things I'm replacing are my u and my dx, okay? Then I say, do my x's cancel out? And if they do, what I get here is 1 over u du, okay? And there's several ways I can go here. I'm going to ask myself, is this an easy antiderivative? Okay, if I look at this and I say, oh, I think it is an easy antiderivative. You just need to move the bottom up, okay? It's an easy antiderivative. You add 1 divided by ding, 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 ding. Did you hear the ln bell? Okay, so when you hear it, you're like, oh, maybe I shouldn't have, changed that. If I just left it like this, is this something on my formula sheet? It is. What is it? ln of u plus c. But my u was x squared plus 1. So you can come back in and put in your x squared plus 1. Those of you guys who like u substitution, keep at it. That's totally fine, okay? But yesterday I showed you a shortcut, okay? And that shortcut was, if you make your entire bottom your u, now you can't just take part of the bottom, because the formula is the integral of 1 over u du. The formula is the entire bottom is your u. Then, if you take the derivative of this, now what's the derivative of x squared plus 1? 2x, and you divide on the top. But you have to use real algebra. Some of you guys are using that fake stuff, okay? You got to use real algebra. And so that's 2x over 2x. Do my x's actually cancel out? Yes. What do I have left? 1. So this answer will be 1 times, of course 1 times, you don't have to write the 1 times, ln of the u, okay, which has to be the entire bottom plus c. And did I get the same answer as when I did u substitution? Check, okay? Now, when you move over to this side, this is what students do. And I'm going to show you what they do wrong. They'll be like, oh, ln, every fraction is an ln, okay? So I'm going to say the derivative of x squared plus 1 divided by 2x, nice. ln of the absolute value of x squared plus 1. Oh, my whole denominator. Don't forget my whole denominator. There I am. I love shortcuts, okay? What did I do wrong? What did I do wrong? What did I make my u? You see I made my u this because I took the derivative and said this was 2x. You can't do that if you're doing a shortcut. You have to take the entire thing and take the derivative of the entire thing. Now you guys tell me, what is the derivative of this entire thing? What rule am I going to have to use? Chain rule. So that would be 2 times, leave the inside alone, take the power down by 1, multiply by the derivative of the inside. Okay, guys, let's use the real stuff, okay? Using real algebra, not that fake stuff, okay? Do my x's cancel out? All my x's. For sure, these cancel out, right? Do all my x's cancel out? No. So guys, this is not an ln problem. Is everybody good with how to do the shortcut? I love it that you guys know the shortcut and you can do it, but I want you to pick the right times to do it. So this problem is just a u sub, okay? So you wouldn't make the whole bottom your u because obviously that didn't work. So what you'd have to do is you pick the parentheses as your u. And you guys are comfortable with that, right? The parentheses is usually your u. You take the derivative of this. The notation for derivative is du over dx 2x, okay? Then I'm going to solve for dx. I'm going to force this into a fraction, cross multiply. And I've done this enough times I can actually do a little bit of a skipping a step there. And then I replace 2 things, okay? What 2 things am I replacing? I'm replacing my u, let me circle that. I'm replacing my dx, let me circle that. I'm going to rewrite everything that I didn't circle, okay? I'm going to copy my dx right here, that's du over 2x, and I ask myself the question, do my x's cancel out? Yes, actually even my 2's cancel out. which didn't have to happen, but that was nice. Those of you guys who are retaking the test, please do it my way, and please make sure you can set it up like this. This is the main thing I'm looking for right here, okay? You need to show this right here, or else I can't tell if you're not cheating or not. Yes, Paige?
Sorry, I had a question about the other one that we did.
Uh-huh.
Since it's x squared, do you absolutely have to put the absolute values, or like?
Oh, that's a good point. You wouldn't have to.
Okay.
Yeah, that's a really good point. Yeah, you wouldn't have to. I always do it because I don't want to think about it. Yeah. Okay, right here, guys, the integral of 1 over u squared du. How do I do this problem? It should be an easy antiderivative. Okay, you can't do a quotient rule here. Okay, so you're going to move this to the top. You're going to rewrite it. Okay, it does turn out to be an easy antiderivative. You add 1, divide by -1. So that's going to be u to the -1 over -1 plus Charlie. And that is a great answer. Okay, it's just the wrong answer. Go back and put in your u. So that u is x squared plus 1 raised to the -1 over -1 plus c. That -1 on the bottom is just a little awkward. You know, if you ever divide by -1, it's the same as multiplying by negative. I mean, you know, you could slip that negative sign up, right? So this is actually, if you divide anything by -1, it just becomes negative. All right, so that's your answer. And then this is actually a simplified answer, which they're both good. This one's a little bit better. If you had a multiple choice, it's more likely to be this one, okay? All right, are you guys good on the difference when you can use a shortcut and when you can't, okay? So am I allowed to like pour water on you if you use a shortcut the wrong way? Okay, thank you. All right, you guys learned 2 new formulas, and go ahead and pull out your formula sheet. 2 new formulas yesterday, cotangent u and tangent u. Today we're going to learn 2 more formulas, and that's the secant u and cosecant u. And you can see these are ugly, okay? But that's okay. We have ugly children. We still can keep them, okay? So we're just going to learn these formulas. I'm going to show you how they were derived. You don't really need to know how they're derived. You just need to know these formulas, okay? Go ahead and write those formulas in. Are they in your notes by any chance? Yes, they're also in your notes, okay? So you can copy them from your notes. So I'm going to go ahead and change the screen since you can copy them from your notes. It's nice to have all your formulas in one place, though. You guys are just a walking knowledge of formulas. I mean, look how many you've done so far, okay? Pretty amazing. You know more than you think you know. Okay, all right, let's look at this. The cotangent one we did yesterday, it really was just an ln problem. The secant one, the way it's derived is this, and you don't have to know how it's derived, but I'm just going to show you. It's kind of interesting. If I multiply the top by secant u tangent u, and I multiply the bottom by secant u tangent u, that's like multiplying this thing by 1. It is a weird one, but it's just like multiplying it by 1. If I do that, this is really over 1. So if I distribute this, what I'll get, it's kind of weird, but I'll get secant squared u plus secant u tangent u on the bottom. I'm sorry, on the top. And on the bottom, I would get secant u plus tangent u. And this is kind of interesting, but okay, you guys good? This secant u is actually equal to this long thing that I did. But guys, what would happen if I made this my u? Okay, what's the derivative of secant u plus tangent u? Divide this. What's the derivative of secant u? Isn't it secant u tangent u? What's the derivative of tangent u? What's the derivative of tangent u? Secant squared u. Do my x's cancel out there? Using real algebra, take a look at that. Do my x's cancel out? Actually, that's not an oh boy application, but that's okay. Right here, I'd have secant squared u plus secant u tangent u over what? Secant u tangent u plus secant squared u. Using real algebra, do my x's cancel out? They actually do, because this is secant u, this is secant squared, this is secant squared. These are the same. So they actually cancel out to 1. So what happens here is, since this cancels out to 1, the answer is 1 times the ln of this entire bottom, which is secant u plus tangent u plus c. And that's where they derived this from. This is the integral of secant u du. Kind of funky, right? You can do the same thing with cosecant u, except cosecant has a negative, and so it becomes ln of cosecant u plus cotangent u. Okay, you guys have written that down. So let's do some problems on how this works, okay? So if I wanted to know the integral of cosecant 2x, okay, you've done this before, but I want to do it with you. I've showed you a shortcut for this, but let's just do the long cut just so you understand. This u is not an x, so I have to do u substitution, okay? The u is 2x. The derivative of 2x, make sure you understand, the notation for derivative is not du. The notation for derivative is du over dx, and that answer is 2, okay? Solve for dx here. Force this into a fraction. Cross multiply, and if you solve for dx, you will get du over 2. Okay, I replace two things. What two things do I replace? My u, which is circled, and my dx. Okay, so I'm going to circle those two things. All right, so this is going to be cosecant u times the dx is du over 2. All right, if I were to take this integral, it's a little cloudy here. Let me pull out some scalars. What scalar could you pull out here? 1/2. So if I pull out a 1/2, I get cosecant u du. At this point, this should be something that's an easy antiderivative, easy reverse power rule. Or if it's a trig function, it should be something on my formula sheet. Is this on my formula sheet now? I mean, it wasn't before, but is it now? Yes, so it's really long, but that's okay. Let's go ahead and write it. What is the integral of cosecant u? Negative ln, right, of the absolute value of what? Cosecant u plus cotangent u plus Charlie, okay? And while it's really ugly, what is 1/2 times negative ln? Because remember, this is all multiplied here. That's just negative 1/2 ln of the absolute value of cosecant u plus cotangent u plus c. And so it's kind of ugly, but it's not that hard, right? It's really not that hard if you know the formula for the integral of cosecant u, okay? All right, let's go to another problem. Let's do this one. Okay, now some of this is review. Some of these you should do. You should be able to do. Well, let me just go backwards and make sure you understand the shortcut. Guys, if I make the argument my u, if I make this my u, and this sits on my formula sheet, does cosecant u sit on my formula sheet? Yes, right? There's kind of a shortcut you can do, and that shortcut is you just take the integral of cosecant u, which is ln of cosecant, let me do this, which is negative ln of cosecant 2x plus cotangent 2x plus c. But then don't forget to what? Divide by the derivative of this. What's the derivative of 2x? 2, and that's another thing you could do. Did I not put in my u's on this problem? Did I just only get oh, I did get the wrong answer. We need to come back in and put in my u's. Okay, and the shortcut happens the same way. Now, I just need to give you a caveat. Most students, when they do the shortcut, do it wrong. And what they do is they don't divide by the derivative of your u. So if you're doing the shortcut, you have to divide by 2. Okay, do you guys mind putting your phones away? Thank you. Okay, all right, so let's look at the difference between these two. Okay, so same idea here. Would you like to do the shortcut, or do you want to do u substitution? Okay, does anybody want to do u sub? I'm okay with that too. Okay, let's do the shortcut. Let's see how it works. All right, this is my u. Okay, now only look at the trig function part. Is sine u in my formula sheet? Now it's got to be in my formula sheet. It is. Okay, so what I'm going to do is I'm just going to take the integral of this part. So the integral of sine u would be negative cosine u. So write that down. Negative cosine, but just put in 5x. Everybody good with that? Now here's where students go wrong. You also have to divide by this derivative. Okay, if you're going to use a shortcut, you got to know all the parts, because the shortcut, you have to manually go in and divide by u prime. So this is your u. What's u prime? 5. So you have to divide whatever is over here by 5. Okay, so what's this answer going to be? Negative 3/5 cosine 5x. Don't forget Charlie. Do you guys see the shortcut? That's what you can do. But again, the number one thing students do is forget to divide by 5. They think they can just say -3 cosine 5x. It's not okay because you have a u here. You need to take the derivative of it. Okay, so let's try that same thing over here. Okay, now we're only going to look at the trig function part. So if they're polynomials, don't worry about it. Okay, look at the trig function part. Make this a u. Do I have on my formula sheet a cotangent u, an integral of cotangent u? Well, now I do, right? Okay. So what is the integral of cotangent u? Write down your answer. I'm going to give you some time. You can look at your formula sheet if you need to. But what is the integral of cotangent u? Yeah, was it a negative or not? Isn't it ln, cotangent is cosine over sine. Ln of sine u, right? So you copy this u. So 1 plus x to the 4 plus c. Is everybody good? That's the integral of that. Okay, now what you have to do, this is what students forget. You have to divide by the derivative of your u. So what's the derivative of 1 plus x to the 4? 4x to the what? Third. Now, just like in u substitution, your x's must cancel out using real algebra. Okay, over here, do you see my x's canceled out? I didn't really have to worry about it. But guys, using real algebra, do your x's cancel out right here? Why, yes, they do. What do you have left? And so you can just put that right there. Okay, if they did not cancel out, that means you have to make something else your u and start all over. Does that make sense? Okay, you ready to do another one? Here we go. Okay, you try this one. Actually, you can do this. Use your formula sheet if you need to. Use the shortcut, or you can do the long cut. Guys, can you guys have your homework out, please? I'd like to check it while you guys are doing this. So your homework from last night. Okay, Sophia, do you have it? Nice, nice. Did you have trouble with that top one there? Okay, ask about that one. Okay, thank you. Thank you, Sam. And you had trouble with some of these? Okay, ask about it. Okay, nice. And thank you. You had trouble with that one? Several people had trouble with that one. It's just a long divide. Mm-hmm. Oh, okay. Let me just stop because I think you guys are, lots of you guys have trouble with the long divide. Okay, let's look at this secant one. Okay, so guys, we're just going to look at the trig part. This is the trig part. Okay, now if I plug in u here, okay, is there an integral of secant u on my formula sheet? Is there? What is it? Isn't the log of what? Secant u plus tangent u plus c. Is that right? It's really long. Okay, but that's okay. You just take the log, and every time there's a u, you just put in your u's. Okay? All right. Is there a negative here? No, guys, because of this s, do you see it, how this s doesn't start with the c? The answer doesn't start with the c. Like, kill the log part. Don't worry about the log. This doesn't start with the c, so then you don't change the sign. Okay? All right. Then what you do is you take the derivative of your u. What's the derivative of 3 plus 7x squared? What is it, guys? Okay, put it over here, 14x. Now you got to take this 5x into account. You didn't take the 5x into account when you did this integral. Now you got to take it into account. And you ask yourself, do your x's cancel out? Using real algebra, do. What's the answer here? 5 over 14. And making sure you understand, this is everything's being multiplied together. So it's 5 over 14 times this whole long thing. Did you guys get it right? Nice, okay. Do the tangent one. Have you done the tangent one? Okay. Yes, this is your u, right? Just look at the trig part of it. So sometimes you have a lot of trigs together. Sometimes you just have a part. So here's your trig part. On my formula sheet, do I have an integral of tangent u? Okay, go ahead and write that answer then. What's the integral of tangent u? Write that out. And does it involve a negative or not? Yes. Negative ln of cosine u. So put in your u here. Remember, we're doing a shortcut, okay? But the shortcut has a caveat. You have to remember to divide by u prime. Okay, is everybody good here? Guys, on the tangent, do you see what letter this starts with? A C. If the answer starts with a C, guess what you have? A negative, okay? All right, so what is the derivative of 2 plus 5x cubed? Is it 15x squared? Okay, using real algebra, guys, not the fake stuff. What does this cancel out to? Do my x's cancel out? Yes, what does it cancel out to? Okay, it's not 15. Is everyone good with that? It's 1 over 15. Where would you put the 1 over 15? Yeah, like behind the negative though. Does that make sense? So it's really 1 over 15 times, right, times negative, or times negative of this, right? So then the answer would just be negative 1 over 15 times this log. Okay, you guys good with that? Do you think this is easy? Okay, so things are can get a little bit more fun. So let me show you this. Okay, no, fun. Okay, you're thinking hard, but I'm meaning fun. Okay, so if you look at this, let's think about this. You know, I can try to do that same thing that I was doing, but it doesn't super work. Does that make sense? Like, it's not sitting where I can divide things out. Do you see what I'm saying? Okay, so the shortcut's not totally going to work here, but maybe there is another shortcut that will work here. I mean, think about the other shortcut I know. What if I make the whole bottom my u? What if I make the whole bottom my u? What's the derivative of that? Cosine. Do you remember the ln shortcut? Okay, so I divide by the derivative of 1 plus sine t, which you told me was cosine t. Make sure I'm actually taking the derivative correctly. Let me think about that. If I say u is equal to 1 plus sine t, what's the du dx of that? That's going to be 0 plus the derivative of sine is cosine t times the derivative of t. This should be dt, not dx, which would be times 1. So I'm good. It's cosine t. Okay, here's the question. Do my x's cancel out? Okay, what type of problem is this then? An ln problem. Do you guys see that? So right now we're combining your trig stuff with your ln stuff, okay? But you got to follow all the rules. So this cancels to what? 1. So the answer is 1 times the ln of the whole bottom. And you're only allowed to use this shortcut, okay, if you took the derivative of the whole bottom, not just part of the bottom. It's got to be the whole bottom. Do you like this shortcut? If you don't like this shortcut, it'll work the long way too. Do you want to see it the long way? Are you sure? Oh, okay. Then let's move on. All right, let's look at this problem. Okay. Now you guys work this with me. So do you want to do the shortcut or do you want to do the long cut? Okay, so if it's a shortcut, this isn't a fraction. So I wouldn't make the entire bottom my fraction, a u. Okay, I'm thinking there's a trig function. Let me make this my u. Okay, do I have a secant u integral? Do I have a secant u integral? Yes, what is that? What is the integral of secant u? Go ahead and write that down. It is ln. Okay, so this is ln of the absolute value of secant u plus tangent u. Do you guys see what I'm doing? I'm doing what you think you do the integral by. Like intuitively, you might be like, oh, this is how you do it. But the problem is you have a u, and that u is not just x. That u is 3x plus 1. So guys, if we're doing the shortcut, take the derivative of this. What's the derivative of 3x plus 1? 3. Divide everything else by 3. We've already taken into account the secant u. Everything else now we need to worry about. Do my x's cancel out here? Yes. So what's your answer? 2/3 times this long thing. Guys, can you do this on your own? Yeah, it's not that bad, right? Okay, so guys, you do this on your own. Do this one on your own. See if you can do it. Guys, do this one on your own. Guys, try it. There's nothing like trying it in class while I'm here, okay? There's nothing like trying it by yourself either. Okay, I'm seeing this trig function here. I'm going to make this my u. If this is my u, I've got to have an integral of tangent u. Is there such a thing on my formula sheet? Yes. Okay, so what is the integral of tangent u? What'd you guys get? ln of what? Okay, so negative ln of, is it sine? 1 minus 4x cubed plus c. Bam. Okay, everybody good there. This is the most often wrong answer, okay, except when it doesn't even have the right formula. But let's say you know the formula. This is the most often wrong answer. You have to take into account this u if you're doing the shortcut. What's the derivative of 1 minus 4x cubed? What is it? Just write it down here. What is it? Negative what, guys? 12x squared. Question, do your x's cancel out? Yes. What does it cancel out to? Negative 1/12. Now be careful. This is negative 1/12 times negative ln. What's the final answer going to be here? 1/12 ln of sine 1 minus 4x cubed, absolute value plus c. You guys happy? Oh, is it sine? Oh, yeah, you shouldn't be happy at all. You shouldn't be. This should be a cosine. That's why this starts at the c. That's why this should be a negative. Yes, thank you. And I'm actually super happy that you guys caught that. So that's great. Okay, I did that wrong. All right, let's do another one. This will be your last one. Then I want to answer homework questions, and then I'll let you guys work on your own. Okay, so let's look at this one. You guys do this one. Go for it. Use your formula sheet if you need to. Then start on the homework. It is, well, you could do it with u substitution. Yeah. Yeah, because I'm showing you guys a shortcut. Okay. Guys, write down the answer. I want to check my answer with yours. Now remember, this only works is if this cotangent u is in your formula sheet. Okay, sometimes you have like a tangent x secant squared x dx or something like this. I'll say 2x. It wouldn't work for this, okay? Because if you made this your u, okay, your formula sheet doesn't have a tangent secant squared u. Does that make sense? So that shortcut would not work for this problem. Okay, it only works when you have like a simple trig formula that's on your formula sheet. All right, so guys, what is the integral of cotangent? Do you remember? Ln, I think this is one I confused because this one's cosine over sine. So this is sine of u plus c. Did you guys get that much? Did I write it correctly? I'm doing this from my head. The integral of cotangent. No, this is not correct at all. The integral of cotangent is, that was right. Oh, sorry. Okay, I didn't get any confirmation. So then I got insecure. Okay, the ln cosine is sine x squared plus c. Okay, that's good? All right. Then guys, if this is my u, what's the derivative of that? 2x. Do my x's cancel out? Yes. What do I have left here? 3/2. Did you guys get this as your answer? Nice. Okay. Let's go to your homework, guys. Your homework, guys, is the, you have some sort of worksheet. What did you guys pick up? Is it, oh, wait, did I put the wrong ones out there?
No.
Oh, you were in first. You were in here first. Okay, here, I'll take that. You do not want to do this. Okay. So what's your homework? Sam, do you mind going outside and grabbing it? I just want to look to see. Okay, your homework is relatively easy, all right? So you guys should be able to do it in class today. Let's go ahead and talk about homework from last night. This is so obvious. Which long division problem do you want me to do? Number 7. Okay, so can I see your number 7? Well, the great thing is that you know it's long division. That's actually the best thing, that you actually know that you have to do long division, okay? So let's think about how you do this. Okay, first, you only look at your first term, okay? Only look at one, because you can only do this one at a time. X times what gives you x squared? X, okay, so you put in x here, okay? Then you have to look at the whole thing. Then you have to say x times this whole x plus 1 is what? So you have to distribute. So what's x times x plus 1? Okay, now here's the terrible part. You have to subtract. Now look what we have to subtract. It's x squared minus 3x, so that's the top. And you have to subtract this quantity, x squared plus x. So, you know, you're really subtracting this thing right here, okay? It's a lot easier if you rewrite it like as a long thing like this, okay? So if I subtract this, do you see that this is negative 3x minus x, right? And so that's negative 4x. So this answer here is negative 4x. Even though it doesn't look like negative 4x, it's negative 4x, okay? What do you do next? Okay, drop the 2. But unlike real division, you have to pull the sign down with it, okay? Then you do the same thing, okay? Drop these parentheses here, you don't need them, and you say, just take the first term, x and 4x, or negative 4x. X times what gives you negative 4x? Negative 4. So then you put the negative 4 up here, okay? Then you do the same thing, but you're only working with the negative 4. You say negative 4 times this whole thing, x plus 1. What's negative 4 times x plus 1? Negative 4x minus 4. Are you guys getting that with the distribution? Okay, Paige? When you've used every term here. So when every term has been used somehow. And so, you know, this was used when you subtracted the x. This was used and when I pulled this down. And then there's no more terms, so I have to stop. Okay? All right, so right here, this is negative 4x plus 2. Okay, make sure you're okay with this. This is minus this whole thing. So this is minus negative 4x minus 4. So this becomes 2 plus 4. Is that right, guys? I'm getting 2 plus 4, which is 6. Am I good on that? My algebra is weaker than my calculus. Okay, I think that's right. Okay, so do you see at this point, first of all, there's nothing else to carry down. Second of all, the power here of your x is smaller than the power here. Okay, remember, even when we did long divide, like if you did 15 divided by, well, that's not a good example. Let's say 7, 51 divided by 7. If I put 7 here, 49, 2. I always waited for this number to be smaller than this number, right? If it wasn't smaller, then I probably went something wrong here, okay? So this number is smaller by power, okay? So this is going to be plus, and what you do is you take your 6, put it in the numerator, you take your x plus 1, you put it in the denominator, and that is your entire answer. What did I do now? So now my integral is the integral of x minus 4 plus 6 over x plus 1. It's a big mess, but 6 over x plus 1. I mean, really, I thought I got to do one problem, but check this out, guys. Oh boy, I get to do 1, 2, 3 problems, okay? And that one problem was like super hard. But guys, check out these problems. Do you see each integral? You just do it by yourself. What's the integral of x? Not 1, that's a derivative of x. Try again. No, that's okay. Okay, I'm trying to defend Colin. Okay, what's the integral of x squared over 2? Oops, x squared over 2. What's the integral of 4? Negative 4x. You guys see where we're getting this? Then what's the integral of 6 over x plus 1? It is an end problem. Let's try it. Make this whole bottom my u. What's the derivative of x plus 1? 1. Divide by 1 here. Okay, do my x's cancel out? They do. What do I get here? 6. So it's going to be plus 6 times the ln of your whole bottom, x plus 1 plus Charlie, and that is your answer. Nice. Did you guys like that? That was so nice. How could you not like that? Okay, let's do number 8. Is that what you guys need help with or not? 9? So you don't need 8? Oh, you okay. So what's 8? Let's flip back to 8. Okay, so 8, guys, is x cubed minus 3x squared plus 5 over x minus 3. Okay, how do you know you need to long divide? No? Well, I guess so. But it could be other problems that you have. What is it? The power up here, yeah, is higher than it, or the same. Even if it's the same, it's kind of weird. But even if it's the same power, you have to long divide. Okay, so let's look at this. X cubed minus 3x squared plus 5, that goes in the inside. Okay, x minus 3 goes on the outside. Now, I want you to do more of it. Okay, so what's the first thing you do? What do you ask yourself first? Yes, x, just only look at the first term, because you can't do a whole bunch at a time. Just look at the first term. X times what gives you x cubed? Okay, so I'm going to put x squared. There's always an answer to this, so don't ever worry like you don't have an answer, okay? All right, then once you get this number here, what are you going to multiply the x squared by? The whole thing here. So what's x squared times x minus 3? X cubed minus what? 3x squared, okay? Now I'm going to subtract, okay? So do your algebra here. It'd be x cubed minus 3x squared minus x cubed minus 3x squared. What do you get, guys? Like subtract this. What's x cubed minus 3x squared minus x cubed minus 3x squared? 0. You get 0. What do I do after I get 0? Bring down the next term. Do you see it? And what's the next term? Plus 5. Okay. Do I stop? Yes, because this power of x is smaller than this power of x. So the answer is plus 5 over x minus 3. Okay. So I thought I got to do one problem, but check this out. Oh boy, I get to do 2 problems. Okay, that wasn't as great as the last problem, I'll admit, but 2 is better than 1. Everybody knows that. Okay, all right, what's the integral of x squared? What's the integral of x squared?
X cubed over 3.
Okay, what's the integral of 5 over x minus 3?
5 ln.
Nice. Some of you guys are getting really good at this. This is your u. Divide this by the derivative of x minus 3, which is 1. Okay, do my x's cancel out? Yes, so this is 5 ln x minus 3 plus c. Okay, you guys wanted number 9?
9 and 10. Yes.
Okay, so let's look at 9. Okay, so number 9 is x to the 4th plus x minus 4 over x squared plus 2. Okay, I think tonight's homework is going to be easier than yesterday's homework. So
Hi, how was it?
he's done with it. Are you done with it? Yeah, he's done with it. Okay. He's actually usually done with his homework in class. So, okay, so that's actually no indication of ease. All right. Okay, let's look at this. What do you do first? What do you put up there first? Okay, so x squared times what gives you x4? Okay, everybody good with that? Where I got the x squared. Okay, now what do you do? Okay, so what's x squared times x squared plus 2? X to the 4th plus 2x squared. Everybody good so far? Now we're going to subtract. So let me put a subtraction sign. Now be careful, you have to subtract the whole thing. Okay, so let me write it horizontally because it's super hard to understand vertically. But horizontally, it's x to the 4th plus x minus this quantity x4 plus 2x squared. And I think I get x minus 2x squared. Did you guys get x minus 2x squared? Okay, here's the thing though. I don't want to put x minus 2x squared because the big term goes first. Does that make sense? So I'm going to put minus 2x squared plus x. Do you guys see why? I don't know if you can see why I did that because I'm going to have to say x squared times what is 2x squared. Does that make sense? Put the big term first. So that's why I'm switching that. Okay, you guys with me so far? Okay, what are you going to do next? Okay, bring down the negative 4. So if I bring down the negative 4, okay, this is minus 4. All right, what do I do next? Okay, x squared times what gives me negative 2x squared? Minus 2. So you put a minus 2 here. Okay, now here's the tricky part. What am I going to do next? Now I'm totally stuck. I feel like I'm almost done, but I have no idea what to do. Whenever you put a number in here, what do you have to do with that number? Multiply it. So what's negative 2 times x squared plus 2? That's negative 2x squared minus 4. Good so far? Okay. So then, again, this is super hard to do vertically. So let me change it horizontally. Now I have negative 2x squared plus x minus 4 minus negative 2x squared minus 4. Some of you guys probably are not doing as many steps as I am. Okay, so this is going to be x minus 4 plus 4. Is that right, guys? I'm getting x minus 4 plus 4. So I'm getting x. Did you guys get x? Okay, can I stop here? Is this power lower than x squared? Yes. Okay, so what does this become? You add whatever your final remainder is. Your final remainder is x over x squared plus 2. Is it getting any easier?
Yeah, that was really easy.
Okay, so it should feel like it's getting easier. Not really because it's getting easier, but because you're getting smarter. Okay. All right, so guys, this is equal to, actually, I thought I got to do one problem. But guys, guess what? I get to do 3. Oh boy, oh boy, oh boy. Check that out. Okay, this is x squared plus 2. Okay, does anybody need me to do this or you guys are on your own? Okay, what's the next one you guys need? Number 10.
The last one, I promise.
Okay, I think it's the last one on the paper, right?
No.
Oh, it's not?
Oh, I already did that.
Okay, so number 10. Okay, ln of x, quantity squared over x. Okay, let's talk about this. It's a fraction, so I'm thinking ln. So let's make this u. What's the derivative of x? What's the derivative of x? Isn't it 1? Do my x's cancel out up here? No. Okay, so not an ln problem. Does everybody see how I eliminated the possibility of it being an ln problem? All right, guys, so it's going to be u substitution. Your u is your parentheses 95% of the time, okay? So make my u equal to my parentheses. What's the derivative of this? What's the derivative of ln of x? Isn't it 1 over x? Okay, cross multiply, guys. Cross multiply, and you'll get dx is equal to x du. Usually you get a fraction here, but actually for these problems you don't. Okay, so then you replace two things. What two things do I replace? I'm going to go back and circle them. I replace my u. What did I make my u? My parentheses. And I also replace what else? My dx, right? So this becomes u squared over x times, and then now I'm going to replace my dx. My dx is right here. That's going to be x du. I have a question. Do my x's cancel out? Using real algebra, is x over x 1? Yes, okay. So what I have left is u squared du. Is this an easy antiderivative or something on my formula sheet? It is an easy antiderivative. So this is u cubed over 3 plus Charlie, and that is a great answer. It is a wrong answer. What was my u to begin with? Okay, make sure, guys, you keep the ln of x inside its family, okay? If you take it out of its family, I'm going to count it wrong, okay? Because it's not ln of x third. It's the ln of x all raised to the third power, and that is the right answer. Okay, it sounds like you guys are good. Yes, which number? Which number? 8? 8. Okay, so guys, we're looking at today's homework, number 8. How could you guys be that far already? Can you see number 8? Okay. Ooh, I like this one. Guys, look at number 8 on today's homework. Okay, I like this one. Okay, check this out. Okay, I'm thinking ln. Are you thinking ln? I'm thinking ln. Okay, so if this is my u, what's the derivative of sine x? Okay, Paula, I need you to stay with us. Okay, so it's negative cosine, right? Negative cosine x. Guys, do my x's cancel out there? No, so not an ln problem. Let's start all over. Okay, maybe long divide. Maybe long divide. Let's not do long divide. Let's just do long divide for polynomials. I'll make a deal with you. How about that? I want you guys to think about this. What if I switch this? Maybe if I switch the numerator part, it'll be good for you. What if I switch this? Does that top look like it might do something for you? No, it still looks bad. It's
It
equal
equals
to
1, right?
Very good. It's equal to 1, right? Isn't that the cost of sin is $1, right? Isn't it 1? So guys, this is really 1 over sine x dx. Okay, keep looking at the front of your formula sheet. Cost of sin is $1. What is 1 over sine though? Cosecant, okay? Cosecant. And I'm going to let you go from there. Okay?
Miss Chang,
Yes.
could you do number 4 on today's?
On today's homework, okay? Let's look at number 4, guys, on today's homework. 4. Okay, do you have number 4, Sam? Okay, secant, okay. And what you want to do on that one is you want to distribute that one before you work it. You want to distribute it. It's kind of like a foiling problem, okay? So distribute it, and I think you'll be okay. Okay, distribute that. I think you'll be okay. Are you not okay? Number 11. Okay, number 11. Now I'll give you guys some hints. Let's see, this is 2 over tangent 3x minus 1 dx. Okay, Yeah, this is definitely not on your formula sheet, right? 1 over tangent. But what is 1 over tangent? Cotangent. Okay, so if 1 over tangent x is cotangent x, what's 1 over tangent 3x? Isn't that cotangent 3x? Okay, so then what's 1 over tangent 3x minus 1? Cotangent of 3x minus 1. Well, pull out your 2. Okay, pull out your 2. Okay, so does that help at all? Yeah, it's a scalar. Does that help at all? Okay, so work it from there.